In our last session together, we learned what Pythagoras' theorem was and where a squared plus b squared plus c squared comes from. In today's session, we're going to learn how to apply or to use Pythagoras' theorem. Let's start with our right-angled triangle. In this example, we have a right-angled triangle. We have recorded that this side of our triangle is 4 centimetres long and this side on the bottom is 3 centimetres long, and in this case we have no idea what this side is here. However, we can use Pythagoras' theorem to work it out, so let's give it a shot. Our first step with Pythagoras' theorem is to label the three sides of the triangle. So, based on what we learned yesterday, we know that the longest side of our right-angled triangle, the hypotenuse, which is also opposite our right angle down the bottom here, is always C. So let's call it C. Our remaining two sides, the shorter sides of the right-angled triangle, are A and B. So let's label them now. Our second step in applying Pythagoras' theorem is to substitute the values for A, B and C into our equation. Let's record that step. So here we go. How do we substitute? Well, we know that A, in this example, has a length of 4. So let's pick up our value for A and put it into Pythagoras' theorem where the A is. Next step is we're going to take our value for the B side of our triangle, which in this example is 3, and we're going to pop that again into Pythagoras' theorem where the B is. So we're substituting our values here. C is what we're trying to work out. So at the moment, because we don't have a value for C, we can leave it as C squared. That's what we're going to solve for today. Our third and final step for Pythagoras' theorem is to solve the equation. So let's solve this together. 4 squared, we've learned, means 4 times 4, which equals 16. 3 squared, we know, is the same as 3 times 3, and that is equal to 9. So in this case, if we add 4 squared plus 3 squared, we're actually adding 16 plus 9. We still don't know what the value of C is though. So let's solve this together. 16 plus 9 is 25. So we know that C squared is equal to 25. But how do we work out how big C is by itself? Well, we do the inverse of squared, which is the square root. So if I square root C squared, my square root and my little squared symbol cancel each other out, and I'm left with C. But what's really important when we're balancing equations is what I do to one side of the equal sign, I need to do to the other. So because I square rooted C to get C by itself, I need to find the square root of 25. And you can use your calculator, or hopefully you can work that out in your head. We know that 5 squared would equal 25, so the square root of 25 is 5. So using Pythagoras' theorem, we've worked out that C is equal to 5. So if I go back to our example over here, we now know that the hypotenuse of this right-angled triangle has a length of 5. Woohoo! Let's try one more example together. So in this particular right-angled triangle, we have one side with a length of 10 centimetres, one with a length of 4 centimetres, and we're trying to work out the value of the other side. So first of all, let's label each of the sides. We know that the longest side opposite the right angle is C, and the other two are A and B. Now let's take the values of each of those sides and substitute them into our equation. So A in this example is 10 centimetres, so let's write a 10 here. A common mistake people make here is that they forget to square the 10. Remember that in our formula A is squared, so we need to be careful that we still square the value of 10. Next of all, let's take our value for B, which is down the bottom here, our 4 centimetres, and pop that. Again, remembering to square 4. And C, at this point, is our unknown. Let's solve it. We can use our calculator to do this. So, 10 squared, using our calculator, is 10, and using our little squared button, 10 squared is equal to 100. And you can use your calculator again if you need to help you with 4 squared. 4 times 4 is 16. Let's add those values up. 100 plus 16 is 116. And then our last step to work out what C is by itself is we need to get rid of that squared. So we do the inverse, the square root. Let's square root both sides of our equation. Over here we're just left with C because these two cancel out. And to find the square root of 116 we use our calculator. And let's round that correctly to 10.8, which means that the length of our hypotenuse in this example is 10.8 centimetres. Well done guys, good luck with today's learning tasks.